Hello everyone, this is Dr. C. Kumar, Professor and Head of the Department of Physics. In this lecture, we are going to discuss about neodymium YAG laser, a topic in laser physics and nonlinear optics. In this video lecture, we will see about what is ND YAG laser, the construction of ND YAG laser, working of ND YAG laser, its merits and demerits, and its applications. There are different types of laser. For example, solid state laser, liquid laser, dye laser, gas laser, semiconductor laser, etc. In solid state laser, the examples of solid state laser are ruby laser and neodymium YAG laser. Likewise, in the gas laser, the examples of gas lasers are helium neon laser, carbon dioxide laser, nitrogen laser, argon ion laser. Likewise, for semiconductor laser, the examples of semiconductor laser are gallium nitride laser, gallium arsenide laser, indium phosphide laser, etc. There are so many types of laser. Among these types of laser in a solid state laser, ND-YAG laser is a solid state laser, and the level of laser in the solid state laser, ruby laser is a 3-level laser, and the ND-YAG laser, it is a 4-level laser. The transition takes place between 4 energy levels. Active center in the ND-YAG laser, the active center is neodymium ions. That means in ND-YAG laser, the yttrium ions are replaced by neodymium ions. A small percentage of weight is doped by neodymium ions, which replaces the yttrium ions. Active medium. In active medium, yttrium aluminum garnet, whose formula is Y3Al5O12, is the active medium in ND-YAG laser. Optical medium. There are different types of optical medium. For example, photon excitation, electron excitation, inelastic atom-atom collision, chemical reaction, etc. Among this, the optical medium in ND-YAG laser is the photon excitation or the optical excitation. Optical excitation means excitation by means of light or a photon. Resonator, for getting a high intensity beam of radiation, the resonator helps in getting a high beam of intensity of light. In the ND-YAG laser, the ND-YAG rod is the ends of the ND-YAG rod. They are grinded and polished and silvered, which act as the mirrors. One is fully reflecting and another one is partially reflecting. Construction of ND-YAG laser. It has an elliptical cylindrical cavity. The name itself says that by looking at the diagram, we can understand that the cylinder which is used for ND-YAG laser is elliptical cylindrical cavity. Because of its shape, it is named as elliptical cylindrical cavity. In this ND-YAG laser, at the center of or at the axis of the elliptical cylindrical cavity, the ND-YAG rod is placed at the axis of elliptical cylindrical cavity. In the ND-YAG rod, the yttrium ions are substituted by neodymium ions. Only a small percentage of weight is doped in YAG rod by ND ions. That is about 0.725% by weight ND ions replaces the yttrium ions. A flash lamp is placed near to the ND-YAG rod, where the light from the flash lamp falls or passes through ND-YAG rod. The flash lamp is discharged by means of a capacitor, and the discharge is initiated by means of a high voltage source. In ND-YAG rod, the ends of the ND-YAG rod, they are highly grinded and polished and the silvered accompanied with mirrors. One is fully reflecting and another one is partially reflecting. Working of ND-YAG laser, we could see the energy level diagram of ND-YAG laser. There are four energy levels. That is why it is called as the four-level laser, starting from E1 to E4 level. When the xenon flash lamp is switched on, the neodymium ions are excited from the ground state energy level to a higher energy level above E2. The ions from the higher energy level, that is from the E3 energy level, they gets transmitted to E4 energy level by means of non-radiative decay. Once when the ions get accumulated at E4 energy level, and when the population inversion takes place at the E4 energy level, the ions at E4 energy level, they are no longer stable at E4 energy level, because the E4 energy level is a metastable state. The lifetime of the ions at E4 energy level is a very short period of time, because it is a metastable state. At E4 energy level, the ions at first spontaneously gets transferred to E1 energy level. These spontaneously emitted photons again triggers the ions at E4 energy level, thereby creating a chance for the emission of photons. Thus, the stimulated emission is taking place um, from the E4 energy level to the E1 energy level. These stimulated emitted photons get further resonated by means of the grinded and polished end face of the neodymium YAG rod. Once when a highly intense beam of light is accumulated, the beam escapes through the partially silvered mirror. A laser light of about 1.064 micrometer is emitted through the partially silvered mirror. The transition again takes place from E4, E1 energy level to E0 energy level, and this is a non-radiative decay transition. During the process of laser action and the xenon flash lamp is working, an intense beam of heat is generated in the setup. In order to further continue the process, the amount of heat generated should be cooled. So there is an arrangement which is made to reduce the heat inside the system. It is done by means of blowing air into the system or by circulating water into the system. So when the xenon flash lamp again works or functions, again the neodymium ions which are at the ground state, they get again excited to the higher energy level, and thus the process continues, which ultimately results in the laser action. A continuous process takes place for the further emission of laser light. Let us see the merits and demerits of ND-YAG laser. The merits of ND-YAG laser: it is easy to maintain, and we could generate a high peak power in this ND-YAG laser. When we use a xenon flash lamp, the output is a pulsed output, but when we use a halogen lamp, we can get a continuous output. So we can get either a pulsed output or a continuous output, whichever we desire. That type of output can be obtained from the ND-YAG laser. And also we could see that output power is about 2 into 10 power 4 watts. And coming to the demerits of ND-YAG laser, the efficiency is very low to about 0.1%. Applications of ND-YAG laser: since the output power is more, it is used in the field of communication, that is for a long distance communication. Also, it is used in the military field for remote sensing. In the field of ophthalmology, that is in the medicinal field, it is used to correct the posterior capsular opacification, and also again in the field of the medicine, it is used in oncology to treat benign thyroid nodules. Also, it is used in the field of industry for drilling, welding, cutting, engraving, etching, etc. Finally, I conclude that we have learned about ND-YAG laser, how to construct ND-YAG laser, and also we have seen the energy level diagram of ND-YAG laser and the applications of ND-YAG laser. Hope you could understand about ND-YAG laser. Thank you for watching.